Okay, the method of differences is a method used for summing series, and this takes advantage of series that are of the form the sum of f of r minus the sum of f of r plus 1, for example. From r is 1 to some number n, which might be a number, it might be a general case n, or it might even be infinite. What does this series equal? Well, what happens is when you plug in f of 1, you'll get f of 1 minus f of 2. When you plug in r is 2, you'll get plus f of 2 minus f of 3. When you plug in r is 3, you'll get plus f of 3 minus f of 4. And what you're getting is that terms cancel as you go along. The minus 2 from the first cancels with the f of 2 from the second. The minus f of 3 from the second cancels with the plus f of 3 from the third, and so on. That will cancel with the one down there. And you can carry on the pattern. F of n minus 1 minus f of n plus f of n minus f of n plus 1. That'll be the last term, if there is a last term. And we can see that that one would cancel with the one before it. The f of n cancels there. And we're left with then just two terms. So this whole sequence, this whole series is just equal to f of 1 minus f of n plus 1. And that's the idea of the method of differences. It cancels lots of terms. And the idea of it in examination questions is to copy out enough of the terms to show that you can see the cancellation pattern and then hence state the result. Okay. So let's have a look at an example. First of all, we're asked to show that this is the case, and then we're hence asked to find this summation, which will be the method of differences part, and then as a little one marker at the end, we're asked to find what this series tends towards as n tends to infinity. So, first of all, this first part is just a little bit of algebra. So part I, actually going to do this in purple. So part I, I'm going to cross multiply this. You can either cross multiply this to show that the right hand side equals the left hand side, or you could use partial fractions on the left hand side to show that equals the right hand side. It doesn't matter which you do, both will give you the marks, but it's easier to go from right to left mathematically. So 1 over 2r minus 1 times 2r plus 1 over 2r plus 1, subtract 1 over 2r plus 1 times 2r minus 1 over 2r minus 1. Okay, so that's me cross multiplying. So that's going to be 2r plus 1 on the top of this one, minus 2r minus 1 from the top of this one, and that's all over the common denominator, 2r minus 1 times 2r plus 1. Simplify the top. 1 plus 1 is 2, and 2r minus 2r is 0. So we've got 2 over 2r minus 1 times 2r plus 1 as required. Okay, so that is that. Part 2 then. Part 2 has asked us to find this summation. Now, just before I go any further, I am going to highlight the fact that this has got the number 1 above it, but this has got the number 2 above it. And that is very important because it is very easy to miss that, because it actually changes the whole series. So the series I want to find has got a 1 above it, but my identity has got a 2 above it. So I'm first of all going to change the sum to be a half times the sum of 2 over 2r minus 1 over 2r plus 1 from r is 1 to n. Okay, so I've times each term by 2, add them all together, and then divide the whole series by a half. And that's clearly going to equal the same as this. And now I can use my substitution in here to say this is going to equal a half times the sum from r equals 1 to n of 1 over 2r minus 1 minus 1 over 2r plus 1. Okay, and this is my f of r, subtract f of r plus 1. Okay. So, let's do the method of differences. So I'm going to take the half out and just leave it floating out there. I don't need it right now. And plug in r is 1. So I get 1 over 2 minus 1, so it's 1 over 1. Minus 1 over 3. Plug in r is 2. I'll get 1 over 3. Minus 1 over 5. Miss a few terms out, because you don't know how many terms there are. Plug in n minus 1. So that's going to be 1 over 2n minus 3. Minus, plug in n minus 1 in there, I get 1 over 2n minus 1. Plug in n, I get plus 1 over 2n minus 1 plus 1 over 2n plus 1. And show the cancellation. The third cancels, the fifth will cancel, that will cancel with the previous one, and that will cancel with that one. And we're left with 1 plus, sorry, that should be a minus there. 1 minus that times a half. So therefore, the series equals a half into 1 minus 1 over 2n plus 1. So just to summarise, therefore, the sum from r equals 1 to n of 2r minus 1 times 2r plus 1 under 1 is equal to a half times 1 minus 1 over 2n plus 1, which equals a half minus 1 over 4n plus 2. And then I can multiply top and bottom of this by n plus 2n plus 1, sorry. So I get 2n plus 1 over 4n plus 2 minus 1 over 4n plus 2. And that's going to equal 2n over 4n plus 2. And that is my answer. Okay, that is what this series equals. Okay. Part 3 of the question was to state what value this series tends towards as n tends to infinity. And if I go back to this one, rather than this line's easier to see, as n tends to infinity, this fraction is going to tend to 0. So as n tends to infinity, 1 over 4n plus 2 is going to tend to 0. Therefore, the sum is going to tend to a half. Okay, so that's going to go to 0, so I'm left with a half. And you can see that here as well. As n tends to infinity, this becomes negligible in comparison. So you're left with 2n over 4n, the n's cancel, and you're left with 2 over 4, which is also a half. All right.